Today's agenda is again brain-computer interface, how and why. We are going to talk about how and why, how BCI works, and why BCI is very, very useful in the current time, present time. So in the last lecture also, I was telling you that in all my lectures, in all my slides, you will find, a number of images. Me being a person of image, I use a number of images. So look at the diagram. This is what we have understood in the previous lecture, that brain computer interface, where we try to extract some information from brain and we bring into the computer. And probably the application of BCI is something like that, where we can control a device or we can control an arm, whereby what we think, accordingly we can act. So if we think we want to write something, that is possible in the area called as BCI. So today the agenda is as following. How does BCI work? We'll discuss, because in the last lecture we closed it, how does BCI work. So we'll begin with this, and then we'll have some discussion on different types of BCI. Different types of BCI. What are different BCI schemes used in a number of applications? And then the scope of BCI. So in this slide also you can see one interesting picture where, as I mentioned earlier, brain computer interface always works in closed loop. It may not, but it may. It may not work. It's possible that we are receiving the signal from brain and the signal is decoded. We extract the features. Signal is decoded by the computer using ML or AI technique, and the signal can be used to generate the commands, and those commands can operate robots, toys, or assistive devices. In that case, there is no need of having closed loop system. But wherever you have rehabilitation, attempting to correct the disorder or disability by feedback signal, there you will always have, closed loop system. As you can see in this diagram, the brain signal is extracted. It may be thought or some stage of your mind, that is input to BCI, and then it goes to the application. BCI is not a simple block. BCI includes a number of things, like you acquire the signal, look at the diagram, and then after acquiring the signal, you send it to pre-processing. In next lectures, we will discuss what type of pre-processings are needed, why pre-processing is needed. I can give here some example of.
One student is waiting in the waiting room.
Okay, are you not able? It's interrupted. So I was telling the example of pre-processing. One example may be, when you are capturing the signal, uh, the subject in the area of brain-computer interface or the medical science, we call a person whose signal is recorded as a subject. So the subject is always advised to be calm, not to move any hands or any other, body parts. Even sometimes, the subject is advised not even to blink the eyes. But it happens. What will happen? The signal which is acquired from brain will have or will be affected by some unwanted effect. That is due to blinking our eyes or our abrupt movement, which is not allowed, and probably due to power line interference also. You have connected a number of cables, electrical cables, through which the signal is coming. If there is any fluctuation in electrical signal, that might also cause the disturbance in the signal. And for that, we use pre-processing. So when you actually work on BCI models, all these stages are very important. You can work on BCI for any application, right from robotics to healthcare. This stage plays a significant role. However, these days, by emergence of deep learning and other models, sometimes the artifact or the noise or the unwanted effect is taken care of by itself sometimes. But it is always better to correct and make the signal very correctly. So then what does it do? The pre-processed data, we believe that the signal becomes appropriate, it goes to feature extraction. So again, it's not a block. You can extract any suitable features. I have told you in the last lecture the importance of the features. Any classification, understanding, interpretation of signal is not performed directly on the basis of signal. What I'm trying to say that in the last lecture, you have seen how does EEG signal look like. So there are standard waveforms, and only on observing the waveforms you cannot perform a number of tasks and you cannot generate different commands. So what do? We try to extract appropriate number of features. Features may be any statistical features, power spectral density, mean value, standard deviation, wavelet coefficients, and so on. There are a number of statistical tools, wavelet coefficients, power spectral coefficients, time domain coefficients, frequency domain coefficients. They can be extracted depending on what application you are talking about. So we extract the features, and the features, as I was mentioning in the last lecture, the dimensionality of feature is huge. So you can also choose most appropriate features. So for that, you can use some optimization method. We will discuss with a particular example in coming lectures. And then the features are subjected to classifiers. Again, the classifiers are ML models, AI models, which are used to classify the features into suitable categories. Based on those categories, we can either generate suitable commands, or we can, uh, use at a control signals for the application interface, and that application interface may even be used for generating the feedback signal in the rehabilitation method. I was telling you that in healthcare, even the correction of some disability or abnormality in the brain signal is possible by sending back visual or auditory or haptic kind of signal to the brain, and the it kind of reverse engineering. We try to correct the deviation or the disability, and this is how closed loop system works. So you can see here that the signals are acquired, and the person can either perform the task, or some ability of his arm which was not working properly could be augmented. We will talk about all these things. So how does it work? I think this diagram is very similar to the previous diagram. How does it work? Look at the diagram. It's same. We have acquired the signal from brain. It goes to pre-processing. So this particular part is signal processing. That is processing. You can also say processing, then feature extraction and classification. These are under signal processing. You process the signal in such a manner that you get some meaningful information. And the applications include numerous applications like computer neuroprosthesis, spelling devices, virtual environments, and so on. So the computer chips are programmed in such a way that it converts neural signals into action, and BCI decodes the signals and translate them into meaningful commands to act an output device to accomplish the user's intention, what user wants. So if you can see this interesting diagram, there has been enough amount of research going on in the area where the human brain can control a number of tasks. As you can see, there are drone swarms are there, and these drone swarms are simply controlled by the human brain wirelessly. You know that all these swarms are working in a wireless environment only. So you can just decode some signal, and whatever is the thinking, whatever the human brain wants, the way in which it wants to control, that controlling mechanism is possible. Even if you want to get some feedback about the monitoring of these drones, the movement of the drones, is there any some issue related to surveillance, the intrusion, something like that. The drones are deployed in this, in these days in the border areas wherever there is a conflict between the two countries, two nations. There also this kind of application is being attempted. So BCI has immense benefit for people with disabilities. I think this point has already been covered, particularly the paralysis or to regain control of their limbs. So remember, believe me that that ability which was lost, it can be that ability can be regained by using a suitable feedback signal to the human brain. It can also help them to express their thoughts, write text using cursor and spell on the computer screen. This is what was written as a speller virtual environment, something like this. And then with BCI, soldier can control the drone swarm rather than covering the entire region geography by all the soldiers. The drones can be deployed, and the drones, you all know it very well. The drones are equipped with a lot of vision capability, computer vision capability. So they are already capturing the vision related data. But under a number of, unseen circumstances, the movement, the tracking, or the control of drones could be an important issue that is a security threat. So this is to keeping this in mind, the brain can control all these drones. In the healthcare, I mean, these are the major stages where you can find some research work in the area of healthcare, like you can definitely contribute with the help of BCI in the field of prevention. It may, encourage the people to stop smoking, alcohol, motion sickness, etc., etc. Detection and diagnosis like tumor, brain disorder and disability, sleep disorder and disability. This is the area, especially the last one, sleep disorder and disability. My team is closely working with one of the practical research lab where they have a sleep related data. They ask the persons to go for the sleep, and then they acquire the signal and they estimate. We assess the quality of the sleep, and we also associate the quality of the sleep with the person's the biomedical parameters, the history of his health and other parameters. Then comes rehabilitation and restoration. Rehabilitation is something by which you can rehabilitate, help the person to lead quality life. And restoration, where there is some loss of ability of particular arm or the organ that can be also restored. So brain stroke is a case, disabilities, psychological disorders are being assisted by BCI in the healthcare. So prevention, detection, diagnosis, rehabilitation, and restoration. Mental state monitoring function has helped and predict and death health issues such as abnormal brain structure, such as brain tumor, seizure seizure control like epilepsy, brain swelling. So you see that even if there is a tumor, even if there is abnormal growth inside the brain, there is possibility, you say, like seizure control in case of epilepsy or Parkinson's disease. Wherever there is some abnormality related, either due to behavioral abnormality or maybe dimensional abnormality. Because you have seen in the last lecture, there are different regions like parietal region, occipital region. So all those regions are associated with different abilities. So even if there is a brain tumor, a particular part where probably say cognitive ability is there or critical thinking ability is there, and if it is not working properly, even if a person is normal, person seems to be normal, but that area is not providing the correct reflection what it is supposed to in terms of critical thinking or the normal thinking ability. So that region might be affected by any abnormal thing, including the brain tumor as well. So why BCI is necessary? As I mentioned, that why is also important thing that we'll consider. And I can tell you, this is really alarming situation. Very recently published paper, it reports that 25 to 50% of cases of adult mental illness. If you remember in last lecture also, I tried to present you one scenario where how many people are, undergoing different types of mental stresses and mental disabilities. So there is a latest survey that says this is included in this paper. It reports that 25 to 50% of cases of adult mental illness can be actually prevented through early intervention. Hope you understand the term intervention. So if what is important in this area is people do not trust. That's a major challenge in BCI. You also are aware about, driverless car, self-driving car. There are a lot of apprehensions. If you are in your campus, in your university, and in evening, now you are after closing up your classes, you want to go to your home or hostel, and probably if someone sends you a driverless car for you just for ride, probably you will have apprehension that you will be uh, thinking that whether the ride would be without any accident, averting the difficult situation or not. That thing will be there. So what I'm trying to say, that apprehension, that resistance, and is there. So all such things. So you need to encourage the people that you can go for screening. Mass screening can be allowed, where they can be asked to provide their data related to sleep, related to other parts of the body, especially we are talking about mental health. So the participants can be encouraged to just to provide their data related to brain EEG data or other data, so that at mass scale, at large scale, the analysis can be made, and the persons can be suggested that this is a very early stage where you are not having normal sleep and some stress is causing difficulty for you. So you can definitely you know go for that early treatment. So this is possible. So the child in childhood, the graduate students have 8 times. The survey further says that in childhood, the graduate students have an 8 times higher rate of severe depression and anxiety. I don't know whether you agree with me or not, but this is a report. Uh, is there anyone else waiting in the lobby? Yeah, anyone else waiting in the lobby, please? Okay, no one is waiting. All right. So this is one interesting picture I have included. Look at the interesting picture carefully. The mental health promotion is there starting from bottom, universal and selective at risk. Like this area, green area is the area where if you can detect the cases at early stage, you can subject them for prevent, indicated higher risk. So whenever you are going towards bottom, the entire half circle, semicircle is the risk area. When you go towards this side, that is left side bottom, towards bottom, there the prevention is possible. And after certain stage, if you can detect, then treatment is needed. And you always understand and you will agree with me that mental illness is such thing. After certain stage, recovery is very difficult. So maintenance will be required, long term treatment and care will be required, rehabilitation will be required, long term treatment, relapse prevention, huge amount of maintenance, the money and all that, the time, stress, the involvement of family, so much things are a role plays role. And the middle one, it requires treatment, illness, early treatment, standard treatment. But before this treatment stage, early intervention is possible. So this is the one resulting picture based on this survey. So at early stage, if the mass screening is so what I'm saying is that we have to work a lot in the area, and then if the IoTs are being developed, we can use the IoT, the medical Internet of Things, or biomedical Internet of Things. Let's say these days easily the we are getting the EEG devices, portable EEG devices. We can capture EEG devices. But remember one more thing, in all this survey and study, ethical issues are always involved, irrespective of the country. When you want to study something on the biological parameter of a person, you have to get the clearance by the ethical committee. So ethical committee is generally it is constituted in the universities or with the consultation of some medical experts. So a committee sees whether there is any violation of ethical issues while capturing and recording the data. So that is very important in BCI. You have to take care of the ethical aspect. So this particular a slide tells us that actually the situation is alarming, and in the alarming situation BCI could actually play a very important role. That's the idea. I have included some more practical examples what we are or what I have been doing in my institute related to the role of AI. Because in the beginning I was asking you that why you are interested to join these lectures. So you said you are very excited in AI. So how does AI play important role? I have some examples like the intervention of AI. AI intervention can be seen in the smart and cognitive system. You all understand when I say a system as a smart system means that is AI empowered system, AI enabled system. If the system has all the abilities of sensing, actuation, control to interpret, analyze a situation and make decisions based on data captured, and that too the decision can be made smartly and adaptively, then the system is called as cognitive system as well as smart system having ability to actuate and to provide control signal, to also interpret a real-time situation. I mean, the real-time situation is there in all self-driving car, the robot devices used in healthcare, they have the cognitive ability. I mean, either pre-trained or in the real time, you use DL or other models. And therefore the systems need to work smartly as well as adaptively under any unprecedented situation it is supposed to work. So on the center of all these smart and cognitive system, your brain is there. Even if I talk about AI enabled system, what is AI? AI is nothing but the system mimics like human being. You call it as artificial intelligent device, and then it can be implemented anywhere. This is an interesting diagram. So when we talk about cognitive system or a smart system, there are three important things which are involved. What is the first one is sensing. So whenever you are designing something for BCI as a smart system, you have to have arrangement for sensing, and then data must be small, and then the connectivity. Because especially when you work on edge devices, you might have heard about edge computing where you cannot, bring everything to the cloud. Rather than bringing everything to cloud, you can have a smart IoTs at edges at different points where you want to deploy. And there some small microcontroller can be implemented and can perform the task and interpret the data there itself. So, and I can tell you the area of AI is so rapidly changing that few years ago people used to talk about big data, big data, big data. Now people do not talk about big data. Rather, I was attending some conference where I heard a professor saying that people should concentrate on small data actually. The data which is a very small data, it has huge meaning. So now the time has changed. The every small data, every small data has a huge amount of meaning. So we need to actually take care of a small data. That is something which is very important. So the smart system implies smart data connectivity and sensing, and the applications may be any numerous applications like smart city. We are working on a project called a smart city in my institute, funded by a Japanese company as a industry supported research we are doing, and then manufacturing, construction, and mining areas, agriculture technology. There are a lot of work where artificial intelligence is being used. I don't want to talk about all these things in much detail because our course is on, I'm sorry, cognitive science. It's BCI role. So here, not much of BCI is used. Energy, smart energy, smart grid, healthcare, transportation, smart transportation, smart parking, smart monitoring, driverless car. All these are very well, covered under what we call as smart or cognitive system. Yeah, any more is waiting? I don't know. There is some alert which is coming. Any more is waiting? No. Yeah. Thank you. So I was talking about edge computing, especially in the healthcare in years to come. In time to come, when BCI becomes very, very popular, is definitely gaining popularity. But BCI becomes very popular in the IoTs. I mean, BCI comes at the IoTs level. What is important is edge computing, and you all understand what is edge computing. Where otherwise, see, you have Alexa devices or other devices, whatever you do, it always goes to cloud for understanding. And you know that network issues are there, then that delay is there every time the signal goes to the cloud, it comes back to the device. So edge devices where it notes itself, but application itself, you can understand the data, you can interpret the data. For this, smart sensing is needed. And what is more important is the communication capability. So you all are aware that 5G has already rolled out in different parts of the world. I mean, including, I think, your Italy as well as India. And the people have been working very, rapidly on 6G technology. So when we are talking about deploying BCIs at the level of edges, especially to deal with, reaching out to the masses as a healthcare service, we also need to think about the communication capability. So
Excuse me,
distributed
there are
computing paradigm that aims
more
at reducing.
elderlies in the waiting room.
Yeah. So the distributed computing paradigm that aims at reducing bandwidth and the response time, because what happens when you depend on cloud, the response time is increased. So you can considerably reduce the response time when we go for edge computing level. Let us understand what do we mean by community well-being and wellness. Because when we are saying that BCI is used in healthcare, a number of times we are using the term. So, community wellness or well-being, is it really area where BCI could be of important role? The answer is yes. And there are different areas which are there under community well-being. Education and learning, whether person is having good learning impact, learning outcome, the learning is helping to transform him or her as a good, either professional or a person, sense of community, cultural identities, community health and safety, access to country, leadership and influence, economic strength and development, infrastructural services. All these areas are covered under community well-being. But especially when we say community wellness, actually this mainly focuses on community health. So this is something which says community well-being is a holistic approach. If you are aware about United Nations development goals, people talk about sustainable development goals, UN goals. There it always talks about holistic approach, holistic development of a person that is incomplete without social, economic, environmental, cultural, and political factors for the communities to lead the quality life. So quality life doesn't only come from the community wellness, rather it comes from good amount of learning, good amount of education, quality education, your responsibility to the community, how community is giving you back, how much you are giving them back. There are so many factors. So community wellness encompasses patient-centric approach in the healthcare. So let us come to the mental health research. Let us narrow down our community wellness to mental health research. I'm going to give one example how BCI as an application is helping in my own institute in one important research work where we have been working with the industry. So what is mental health research? Again, mental health research is on the in the center there is a brain. And mental health research deals with studying behavior, studying physical abilities, physical functionalities, whether there is any disability in the movement, signaling, being responsive and reactive to the environment. Do I have any disability that I'm not able to actually sense something? I'm not able to actuate something. I hope you understand the meaning of sensor and actuator. Generally we say sensor So what happens that we are watching something, so stimuli is converted into what I can say is equivalent signal. If your mobile phone has a sensor, it is converting the signal into electrical. But in actuator, what happens like robots, you know, electrical signal is converted into mechanical, so some movement is taking place. So that is included in the physical function, emotion, sentiments, study of sentiments, study of emotions, then perception or sensing, thinking or cognition ability. All these are the important components of mental health. So emerging area of research using various modalities of brain. I have told you the modalities of brain, but don't worry, we will discuss all the modalities in detail. Especially we will highlight more about EEG because in most of the BCI systems, EEG is being used very popularly and widely. So this is something you have to explore the ability of brain. You have to reach out to the brain and exploit its ability. So I just want to tell you that in my team we are working in this area closely. I have just included some last 2 to 3 years publications, which are means very relevant to the area where we are talking about BCI and healthcare. So this is a book which has been published this year only with the title Machine Learning in Healthcare. So you can see that this is particularly AI in healthcare. So how does AI help in the healthcare? It is available online as well. This is a textbook which came this year. I'm not promoting the book. I'm just telling you that if you really put the effort and just try to contribute, to some extent in this area, not only doing a research or a project or getting a good research opportunity, good university, you can also produce these kind of outcomes. It gives you visibility, connect connectivity with the globally working people in this area, and it also gives you the opportunities. Of course, it also helps you generate some revenue. Of course, there is other book, AI based BCI. Look at very particular book, artificial intelligence based BCI, and this is edited book, not the textbook, where we have some combination of chapters, and this has been published in elsewhere in this year only. And in year 2020 there was a book, GR, that edited book on advances in modern sensors. It appeared in IOP Publishing, UK. And there is another book, this came in IEEE Sensor Journal. Those who are in the publication area, they understand how important these journals are. So IEEE Sensor Journal, there was a paper, a thresholding free state detection. Look at here, approach for home appliance based control using P300 based PCI. This P300 based BCI is an important type of BCI. Let us not discuss about this. We will discuss P300, what is P300 in detail in coming lectures. So there was another paper in 21, it has been published in elsewhere, detection of sleep apnea. This is another problem with related to sleep. You look at here using ECG signal. Probably it is EEG signal. Yeah. So based on biomedical signal, we have studied how can we detect the sleep apnea. There is another work, again, it appeared in IEEE Sensor Journal 2 years back, statistical wavelets with harmony search optimal feature selection of EEG signal for motor imagery classification. So look at this title is very interesting. Motor imagery classification means what kind of movements a person is doing, and look at is very carefully optimal feature selection. I was telling you that when we talk about the features, you need to select optimal. So there was a method called as harmony search based method, which was used to select optimal number of features. And what statistical tools were used? Statistical wavelets were used in order to optimize and extract the features. So these papers, these works are available. I have already given the link. If you're interested, definitely you can open and read the paper. There was another work. This appeared in IEEE transaction. You understand the role, the importance of IEEE transaction. So in IEEE transaction, there was a paper, emotion identification using adaptable tunable Q wavelet transform. I'm just trying to tell you that, I mean, these are the similar areas where research is possible and research is going on. Another work, it also came in IEEE Sensor Journal, cognitive workload assessment. What is cognitive workload assessment? Say you are attending the classes or a pilot is working and pilot is being given commands by the air traffic control. How much workload he undergoes, how much workload, how much stress he has. That kind of study comes under cognitive workload assessment. So this was an interesting paper appeared in 2020 in IEEE Sensor Journal. And there was a popular method, logical TLBO, teacher learning based optimization method was used. And there were a number of methods which were used to assess the cognitive workload. So how to rank the different methods, classifiers. So Prometheus is a very popular method which was used. I'm just telling you, just to create interest in you that where is AI? Where is AI? Where is role of AI? I'm just trying to tell you. And lastly, I mean, this is a very popular paper. Why you can see, you should see this paper. You can read the first author, my dear friend of University of Sanyo, Sylvia and me, we wrote one paper on advances in smart environment monitoring system using IoT and sensors. So why I'm talking about this, that this was a critical review paper. I mean, those who take interest in research, there are a number of research types, review based research, survey based research, experimental research, qualitative research, quantitative research. So this was purely review based research. And why I'm talking about this paper, in just 2 years, slightly more than 2 years, if you can go to the link of this paper, you will find that it has attracted more than 200 citations in just 2 years. So, I mean, this area is so interesting, so exciting. So people are taking interest and they're trying to do, research in the area of smart system. So this is nothing but an example of a smart system where what is important for us that can help in the BCI is the artificial intelligence, what is called as AI. So community wellness lab, I'm just continuing that because I wanted to just tell you our background related to this. So we currently, there is one more lab I'm handling with. Don't worry about this IKS, which is called as Indian Knowledge System. It has nothing to do with the knowledge, of Hindi or some language of India, but it talks about sustainable environment, holistic ways of living, health consciousness, how we can do some work, and I'm doing one research project funded by the industry in this area. And so when we say Indian knowledge system, I mean, it does not include only about the knowledge. It talks about knowledge in traditional knowledge in mathematics, health and wellness, consciousness studies, astronomical studies, how astronomy, the traditional knowledge of medicines, traditional knowledge of the different consciousness meditation practices can help us in, leading the quality life and, to address the brain disorder and disability. That's the idea. So what are the objectives of this work? To study the impact of yoga. These days, yoga is very, popular all across the world. I hope you all are aware about the yoga. So I have a practical data set on yoga, and we are trying to study what is the impact of yoga on mental well-being, consciousness, and sleep quality. So the persons who are doing yoga, persons who are not doing yoga, there is one specific university. They have a research lab. They are doing that work, and we are trying to get that data, and we are trying to understand how does yoga, impact mental well-being, the meditation, and the quality of the sleep, and to safeguard or improve community well-being through, AI. How AI, if we are using AI, whether it is augmenting the performance of the study of yoga, and to study the cognitive ability and impact of yoga and mindfulness practices like meditation. If some person is, I hope all of you understand meditation as well. And what is the approach in this work? Because this is one similar work going on. So I thought of including this just to create interest in you, because I mean, this is a practical work that has been funded by the industry. It means it has some strength, and therefore, we have received a fund. Otherwise, industries won't provide money for doing research. So what actually we do, we collect the data set from a neuroscience research university in Bangalore. It's not only yoga university, but a neuroscience research university. We obtain different data related to EEG, automatic control, optical imaging, sleep, bioenergy, molecular bioscience. We get all these signals. And with the help of collaborator, they have ethical committee approval. and all those biomedical parameters are taken into consideration. So what do we do next? We analyze the data with the help of the artificial intelligence, how the brain and other attributes they vary in different persons when they do yoga or other kind of practices. And lastly, what do we do? The data set is analyzed on the EEG signal. Suitable AI ML methods we are using to improve the impact analysis, so that the factors, especially the stress, the sleep quality, the concentration, the disability on different subjects can be studied. Means whether there has been any reduction in the stress level, whether there has been any reduction in the, whether there has been any betterment in the sleep quality, whether the person is now able to concentrate better way after doing yoga or meditation. That kind of study we are trying to do. So it's not very much directly associated with what I am saying, that BCI is used to generate command, but BCI can be used to assist in the healthcare. This is some application similar to that. So these are the actual facilities we are using from the neuro science laboratories. We are not working on open source data set. We are working on the real time data set. And the facilities include psychological parameters, cognitive, means there are different labs related to psychological lab, cognitive neuroscience, psychology, bioenergy, molecular bioscience. These are the other facilities where a lot of different types of parameters are extracted. So what is general flow of work in all these applications? Obviously, I must tell you the importance of AI, and then later we will discuss some models in detail, how the models are helping us in implementing the BCI successfully. So the first stage is to collect the data set, then we pre-process the data set, then we extract the features, and those features are probably, they are sent to modality fusion. You can have more modalities as well, not only EEG, but you can combine other modalities as well. And then that goes, for training or understanding, the interpretation. We can use any suitable model. And the idea is to study autism, alcohol addiction, bipolar disorder, dementia, major depressive disorder, and other stress disorders and suicidal risk also. I can tell you one interesting example. You can also find it that is not very much related with BCI, but I'm just telling you the role of AI. Very important role of AI. There is one work where our students studied about that as a reading elective course, which is a 4 credit course. Here we offer as an elective course. There, what did we do? We on the basis of hashtags and some suitable terms which are used on Twitter by a number of persons, we tried to study how many persons are thinking of attempting suicide. So that kind of study is being made, and AI is being used as a great tool in such kind of studies, based on what kind of sentiments the person is expressing, what NLP or what are the the emotions the person is expressing on the Twitter or other social media. On that basis also one can analyze, but there is no direct interface between the brain here. I'm just talking about the expressions and the sentiments which are coming in the form of text. So what we are talking about is a community well-being that covers screening. A lot of screening is needed so that you can save lives. You can encourage the people for mass screening. Then diagnosis can be definitely done. Monitoring, treatment, prevention, self-management. Self-management is an important thing. You have to encourage, and how to encourage? I was trying to give an example. Those who don't, want to do any kind of meditation or something like that, but at least they can be quiet for some time. What is called as meditation is nothing, think nothing, do nothing for some time. That's all. Just try to concentrate on yourself, think about some point, and that's a meditation. I can tell you that's how one can, manage self and control a lot of emotions, and the stress management is possible. Of course, I'm not talking about a true research in the area of BCI. BCI is coming into the picture where there is a problem. I am saying that BCI can definitely encourage the people that, when you are having difficulty, when you are in stress, look at your signal that is deviating from the normal. and it's likely that you can have some brain disorder or disability. So this is how that encouragement can, motivate the people for the self management. That is the idea. Where So let's see one more example where study of frontal brain EEG signals are involved. Here one study was made by the students where the EEG signal was recorded, pre-processed, and then we decompose the EEG signal. As I told you that delta, theta, alpha, and beta waves are there in the EEG signal. So they were extracted, and some PSD and coherence parameters were determined, and then statistical analysis gave some interpretation related to how many people are there undergoing, anxiety. Some anxiety is there. How many people who are, practicing some mindfulness procedures, kind of meditation. How many of them were non-meditators? Look at here, and those who were doing meditation. So how many of them were doing meditation? How many of them were not doing meditation? So it clearly was indicating the difference. The anxiety and mindfulness assessed during self-reported scales prior to each data acquisition. The frequency band, the signal frequency band is given, used for measuring the power spectral density. The wakefulness, relaxation, and internalized attention influence cognition and behavior. So the person who is relaxed, the person who has some stress or attention disability that affect the cognition and the behavior of a person. There was one more similar work, and after that I will definitely start the types of BCI, because I have talked about why BCI, but we need to also understand what different types of BCI are. And then to understand some terminologies about BCI is equally important. So there was one more study done by a student where we involved EEG signal. As I told you, education and learning is also an important component in the cognitive science study. Let's not forget that the course is not only BCI, but on cognitive science as well. So there is a very important paper, one interesting paper is available. I have given the link, I think it's Carnegie only, So in there, some person has done research, and though the data set was very less, the data set was small. So the MOOC deployable EEG devices found promising to capture tutor relevant information. So I can explain you this, what the research has been done, especially during COVID-19. This paper was before COVID-19, but especially during COVID-19, a lot of students had no option but to attend the online lectures. So the massive open source, online classes or courses, how impactful these courses are, how impactful the online teaching learning is. There was an assessment using EEG signal in this paper. So EEG signal was sampled at 512 hertz as an indicator of the signal quality, reported at 1 hertz. Mindset is a small device. Probably it is as I was telling you, the portable EEG devices are coming. So Mindset is a name of device. Probably it's 100 USD around. It was used to attention and meditation signals to measure the user's level of mental focus and calmness, reported at 1 hertz. The power spectrum reported at 1 hertz clustered into standard name frequency bands like delta, theta, and all that. These are the technologies, and the confusion was recognized. So what they have done, they have tried to calculate confusion and non-confusion. How many students were understanding? How many students were not understanding? Like 78.6% of accuracy of confusion of not, and 68% of accuracy in predicting the level of confusion was something, done in that paper. So confusion is recognized with EEG signal, and in predicting the level of confusion, I have given some links. Accuracy of the student, if was confused, was 73% with the LSTM method. This is a popular name of a model called as LSTM. While testing the same work with SVM, because they didn't test with SVM, so we tested with SVM, we found same accuracy. What was interesting is when we use another AI model, we found almost same accuracy but reduced time. So the time computation was less. As I have clearly mentioned that what is important in this research is The number of sample is very less. I think the number of subjects in this study is only 10. So you can understand when you want a better outcome, a better conclusion, you need to have always more number of people. But also at the same time, we need to admit that the getting sample or subjects, especially on medical research, biomedical research, is a tedious task. How can you encourage the people to provide their data? So we have been working on CNN model. Now the students tried to implement CNN model using same data set, and it was found increased accuracy. Can you see that 73.3% to 83.7%? This was not attempted with the reduced time. Sorry. So SVM provided same accuracy with reduced time. When CNN model was tested, accuracy was also improved in addition to the reduced time. In bidirectional LSTM, two CNN layers were added at the front with a dropout layer in between to reduce overfitting. A 3 by 3 filters were used in both the layers, and the number of filters applied is 2 in first layer and 4 in the second layer. This I have included some technical details about the CNN model. And this simple approach, in the same work could provide a better accuracy, and that too with the reduction in time. The time reduction was not so much, but there was, observable reduction in the time. So we are in the process now. What we are trying to do in this area also, because this is a perfect example of BCI where we are trying to understand the brain and we are trying to understand the learning outcome, the confusion, critical ability, critical thinking, all those things we are trying to include. That's a plan. We have not yet started, but we are in the process of acquiring our own data setup around 120 persons, because this is very important thing. If you want to study on this kind of work and to bring good conclusion, then you need to have more number of persons. So we are trying, because we offer online programs also at our campus. So getting subject is definitely one task where we are in the process to create our own data setup around 120 persons. So what is the way forward in this area? AI analytics, cloud services, telemedicine tools, health technologies, communication technologies are changing the fast, and the next generation computing devices, next computing dives, future for healthcare as a front runners, startups and e-health research centers. So, the healthcare is going to be a front runner area in years to come. So there is a term like e-health research center. So in our university, we have e-health research center as well. This is also funded by the industry as well as the government. We have enough amount of money there in that area as well to work. Robust environment monitoring, smart agriculture, new education paradigm. These are the areas where cognitive science is playing, important role. Data remains most important challenge for computing research. I told you that we know that the nature of brain is complex and huge number of channels, not huge, more and more number of channels are used to collect the data to cover the entire brain, and we also extract huge amount of features, huge number of features. So data remains an important challenge in the computing task, not only in cognitive science and BCI, but all computing tasks, data is really a challenging task. And especially where your data is in the form of image and video. So there, data becomes even a huge task. So leveraging artificial intelligence and ML in next generation computing for emerging and fast changing computation paradigms that includes cloud, fog, edge, serverless, and quantum computing environment would again help the area of BCI to make it at larger scale and to reach to the wider geography and the community. Internet of medical things and tools, mobile mental health is the emerging area where people are working. MMH called as mobile mental health. Security and ethical issues are there that need attention in the area of biomedical research. So whenever you start working on BCI or related application in the healthcare, the important thing is the privacy of the data, personal data. Why consent is required from all the persons? Because persons may object that this is my personal data, personal information, EEG or ECG, why, how can you use this for your research? And how can you take it to the level of patent or, converting into a outcome. So these are the really the issues where a lot of work is going on, and the future work depends on that. So as I mentioned that after this we will try to understand what are different types of BCI. I think at this stage, if you have any query, you can ask. As I told you that today's lecture also does not have much mathematics, algorithms, and flow diagrams. So probably, if there is a lot of theory, then sometime you get deviated and then you feel boredom, what's going on. But I believe that this area is very exciting. So I don't, find any reason for getting distracted. I hope you are, enjoying the course and particularly the lecture. Yeah, so if there is no query, then I'll move to the next point. So now let's talk about different types of BCI. So the types of BCI are invasive, non-invasive, and semi-invasive. So let's begin with non-invasive. Look at the picture very carefully. You are not inserting any, what to say, any needle or any electrode inside the skull. You see here there are a number of slots which are empty, but there are some slots where you are capturing the, from where you are capturing the signal. So all those electrodes are connected at these points. So it's important where do you want to place the electrodes? Are you interested in the entire, scalp area? Are you interested in certain area? If your interest is only to understand visual capability, how is the visual capability? If your interest is only to understand the motor cortex ability, whether the person is able to move, properly, whether the person is able to see and understand properly, because you have seen yesterday, mean in last lecture, you have seen that there are different areas responsible for different abilities and functionalities. So look at the diagram. It is not capturing from the entire head, but it is capturing from certain area as well. So what is important in this is non-invasive. There is no, surgery or no needle or no electrode is inserted inside the skull. So EEG is the most popular a modality used to monitor and analyze the brainwave activity that comes under non-invasive. It measures the voltage fluctuations in the brain caused by the ionic current within the brain's neurons. I have explained this process in the last lecture, but I will again discuss in detail how does it fluctuate and how does it produce the voltage. We will try to understand in coming lectures. But what I can say again here, what I have already explained in the very first lecture, that all the neurons, billions of neurons are there, and the number of neurons are there in different groups. So there are always, interactions between those groups, and there is some, stimuli which happens between these. So what happens that some reaction goes from one group to other group, and this is how then finally some signal is generated as an electrical signal, which we see as a EEG. So EEG records spontaneous electrical activity of brain over certain period. Remember, in all research, time is very important. If you are involving 10 persons and you are asking all the 10 persons for the data collection, so the parameters must be same. The duration for one person is say 10 seconds. You want to capture just for 20 seconds under certain environment, that environmental condition, and the 10-second duration has to be same for all the persons. So the non-invasive method is not costly. I was telling you, even the portable invasive, non-invasive based BCI schemes or systems are coming where you can record a EEG signal, and then you can definitely bring to your computing device and you can analyze. Easy to use and work because portable. No risk of scar tissue or tissue damage in the human brain because you are not doing any surgery. So there is no damage involved, but has a lower spatial resolution and captures a weaker signal because of obstruction of the skull. I hope this point you are very well understanding. If you have any doubt, you can ask me why it has a less resolution and why does it capture weaker signal, because the interface is not direct, and in order to provide interface, if you remember, I was telling in the last lecture that we put some wet gel in front of all the electrodes so that it provides the conducive path. The conductivity flow can happen. But of course, there is one skull which is stopping you, which is the barrier, thin line barrier between the electrode and inside the brain, and therefore the resolution is not very good. But despite the fact, EEG is the most popular. The reason is already listed, cheaper, easy to use, and portable as well. And there is no risk at all. That is the major thing. EEGs are mostly preferred by the physicians in the treatment of the brain disorder and disability. Partially non-invasive, there is one modality called as, you read the name here, electrocardiography. The name is electrocardiography. So here, what do we do? We completely don't, do the surgery, surgical. Some opening is made, and in the sensory area, some motor area, yeah, some cheap kind of thing can be, placed there. ECOG electrode, some implantation of electrode can be made inside, and just inside, very near to skull. It's not in depth. So this is what is called as partially invasive. If it is completely invasive, even deeper, to more deeper level, that penetration will happen. Look at this picture where, we are trying to put a hole, and then we will insert this particular electrode complete inside the brain. This is the research where, there is a direct interface between the brain signal and the computer. But of course, the quality of signal, as I told you, will be a excellent, excellent quality of signal. But remember, it's equally risky as well. It requires major surgery where you are inserting the electrodes. So a scar will be there, permanent scar is likely to happen, and then damage is likely to happen. Even that there is always the risk of death when something goes wrong in the surgery process, because you all understand that brain is very complex area, and a lot of complexity is there. So it can record the activity of single neurons with the highest signal quality. You can understand what happens in EEG. A lot of bundles of neurons, they interact with each other, and finally at the surface, you get some pattern in the form of electrical signal. But here, each and every neuron is very difficult actually, because there are millions of neurons. It's very difficult, but still very selected number of neurons. And from that group, you can get the signal quality. And since it is a direct combination, direct interface, so you are getting a good quality of signal, and that too accurate signal, because strength, the signal is strong and is of good quality. That is there. There is no loss. So clinical long-term applications, they can allow severely paralyzed. See what happens, that the people who are severely paralyzed, they can always take risk. They'll take one chance, if there is that treatment, that kind of analysis, we can enjoy our good life, better life. So that we can regain our some of the abilities. So generally in such cases, even the physicians recommend to take the risk, so that some ability can be regained and some autonomy, and increase the quality of the life who are undergoing a kind of severe paralysis, not only the simple paralysis, but severe brain paralysis. It's not the other kind of paralysis. It requires medical professional guidance, and patient needs to undergo surgery to implant the sensor or the electrode in the brain. Whereas in non-invasive, you don't require any medical professional. I can tell you, like mindset kind of devices are coming. Just, wear like your headphone, and just use like a headphone, capture the signal, bring into your laptop, use some AI/ML model, analyze the signal of any person. Of course, it is not ethically allowed in most of the parts of the world. There is always ethical clearance needed, but for a small sample, among your friends, you want to do, because it is not risky, it's non-invasive. There is no risk of life, and there is no adverse effect on the health. So still one can try. So that's the benefit of non-invasive, whereas invasive doesn't have that benefit, and it also requires professional a medical, guidance or the assistance to get the better implementation. So what are the benefits? It converts previously passive devices into smart and active ones. I told you that rehabilitation is possible, regain is possible. So it converts previously passive devices. Those devices are the components or the organs which were not working and functioning properly, are acting like smart and active devices, a kind of prosthetics where some organs are developed, some prosthetic arms are developed, prosthetic legs are developed, where you can just help the people who are in the paralysis, and with little AI ML, they can just control from their hand, and they can just lead a better life, not the quality life, but definitely better life. So it also enables, it means BCI also enables communication using semi-motor rhythms, the area called as semi-motor rhythms, used for also the rehabilitation kind of application. It helps in regaining motor control in paralyzed patients. BCI enabled vehicle to avoid accidents. The vehicles can be controlled by even the BCI environment, where one is self-driving, that's different thing. Their sensors are the human eyes, those sensors are smart sensors. But here we are saying that just brain or the thinkers can control the vehicles and just to avoid the accidents. But this is in the very beginning stage, what I can say, the study stage. Much has not been achieved. Train and the
Excuse me.
BCI. Yeah.
Someone is waiting in the lobby.
Oh my God, still. This helps in regaining control. And then where were we? BCI enabled to avoid accidents. And then BCI also trains people's motor and cognitive abilities to counteract the effects of aging. But again, this is because of aging, many people lose a lot of abilities related to cognitive, motory movement. There, these assistive devices are the areas where, the work is going on. Here we have other colleague in my institute. They have developed some prosthetic, devices and arms and wheelchairs kind of things, and they are trying to operate those wheelchairs and prosthetic devices with the help of brain related signal. So they have achieved a good success, and those things are there in their labs. I have actually seen their work. So a lot of work is going on. It is used in neuro rehabilitation to help people whose neuromuscular function impaired by trauma or disease, or relearn useful motor functions. What are the challenges in this area? Signal acquisition hardware is cost effective, portable, durable, economically feasible, and easy to use. Means this is not, I'm saying, what I'm saying is signal acquisition hardware has to be cost effective. But then only you can deploy it large scale. It has to be portable. It has to be durable and economically feasible, and of course, easy to use. Acceptability is the major challenge. I have already mentioned about this. Acceptability is the major challenge by the general public for daily use when it comes to, when it achieves the reliability of natural muscle function. It's very difficult to convince the people. System obstacles, particularly those related to EEG feature characteristics. Inbuilt problems in the system obstructions, artifacts are always the difficulties. So you are not able to decide then whether the signal being analyzed is correct signal or not, whether it has been, corrupted by some unwanted signal or unwanted artifact or a noise signal. That is very difficult. That makes the analysis very, difficult. So what's the future perspective? Globally, many companies, I can tell you, many companies are working to introduce some proposed models of BCI in coming years. You can find, just Google that which are the companies who are working, in the areas of BCI. But most of them are working in the area of two major applications, mostly healthcare and robotics. What I have visited the profiles of different companies, mostly they are working in the area of robotics. Some of them are working in manufacturing as well. how robots can be deployed in manufacturing, smart manufacturing, and one can control those robots just like, behaving and working like human beings in these smart manufacturing areas. Can immensely benefit many people with disabilities or paralysis. The contribution, these are some companies, like the Cognitics. EGI is a very popular, company. These are some companies which are working. What I found is, otherwise there may be many more who are working in the areas of BCI. So the next part will be talking about something about nervous system. If you remember in my first lecture, I have mentioned about central nervous system and peripheral nervous system. You can definitely, wonder how and why we are discussing about all these a kind of biological studies. Why it is needed is once we move to the application of BCI and understanding the different biomedical signals or different applications, these things are very important. How, say, remember when we are talking about interface and central nervous system is having inside the brain, that is there in brain, and it is connecting with the outside world, what is called as peripheral nervous system. So we need to understand its functionality, and that's the idea of discussing all these things. Right. So this is the nervous system where you can find brain, spine, and remember, yeah, it's not only brain disease. The disease or problems related to spinal cord, that I mean there are research, not enough some research contributions are there that indicate that using even the brain signal, some possible treatment of the difficulty related to spinal cord is also possible. So in fact, therefore, central nervous system not only includes the brain, but this spinal cord till here in, it is included in the central nervous system. So autonomic nervous system, ganglia is the the biological term, and then peripheral nervous system is the outside world, and the spinal nerves are here where you are getting some movement. So peripheral nervous system is the outside where or which is connected with the BCI, and so with what BCI, with the central nervous system, the BCI. So the BCI, I have already explained. How does it work? I think this diagram has been already explained. It's looking little different. You record the signal, recording amplifier. Yeah, when we go for different types of BCI, we will understand different signal conditioning circuit, different, what I can say, signal conditioning, amplification kind of circuits are also required because the signal which we acquire is very weak. So it also needs to be amplified. So it is subjected to amplifier, and then after amplification, it goes for decoding, and then we encode it, and then it can go for a stimulator where we want to cure something, in the some abnormality in the area of brain where there is some problem. So stimulated signals can be generated from the stimulator, and that can go as a sensory feedback in the form of either voice, speech, something like that. Or even the wireless implementation is possible where wirelessly as well, as you have seen one example today, that the swarm drones are controlled. So similarly, these things like sensors and actuators can also be controlled wirelessly with the help of BCI. So what are the functions of CNS? Yeah, after 4 or 5 minutes, we'll have a break for 10 minutes and then we'll continue. So, and then again, after coming back, I would request all of you, please do not hesitate. Just treat me as your, what I can say, a teacher of your own university. I mean, be friendly when it comes to having really some query that is actually either troubling you or creating some, more excitement in you. I may not, I might not be able to answer very quickly all their questions, possibly because this is not an area where, one is supposed to be, or one can claim that the person is expert because you understand the complexity of the brain. So what we are trying is on the basis of EEG signal and the analysis. So the function of CNS, that is central nervous system, is to respond to events in the outside world or body by producing outputs that serve the needs of the organization. So in the next lectures, we'll find out there is a very important term called as ERP that will come like event related potential. So the voltage which is generated, that also depends on what event. Say we are talking with 10 persons and we'll assign 10 persons do this particular task. Say there are some games or puzzles and we'll ask them do these puzzles, correct? So if the persons are involved in the different tasks, accordingly the brain will respond. So ERP and other modalities are there which are very well used, and there the CNS plays important role. So all the natural outputs of CNS are neuromuscular and hormonal. Either hormonal means it generates certain frequency, or either neuromuscular. It also can include some muscular movement. And the BCI provides CNS with a new output that is neither neuromuscular nor hormonal. This measures CNS activity and converts it to artificial output, because now we are talking about outside world. So the output which is generated from the CNS, it goes to BCI, and BCI interprets the system from a signal from CNS, which is used for the replacement, restoration, enhancement, supplements, improvement. What are these terms? I can tell you these are very interesting terms. One can replace, one can restore, one can enhance, one can supplement or improve. Actually, these are nothing but the capabilities, and these capabilities are enhanced or improved by the CNS output with the help of BCI. So therefore the changes the ongoing interactions between the CNS and the external or the internal environment. So look at this diagram very carefully. This looks very interesting. And again, we'll start our lecture from here, though we still have 1 minute. So look at what the terminologies I was using in the previous slide: replacement, restoration, and all the terminologies have been explained with the diagrams. Look at here, replace. Restore means some ability might have been lost, in the human organ kind of body, movement body or motory body, motory element. So it is getting restored. Enhancement, the ability kind of, lot of BCI work is going on using EEG signal for the drivers, who drive their trucks or the different vehicles for a long time. If they go into the sleep, there must be some alarm, or they can receive some alert signal kind of thing. So enhancing that ability, supplementing the ability, and then improvement of certain ability. So replace, restore, enhance, supplement, and improve. All these are actually the applications of BCI, and all these are possible by just using suitable commands. And how do we get those commands? Are again, the process is same. So remember, the stages of BCI are always same. The only thing is there are different applications. So how do we get different commands? How do we generate different commands? So what you love about is artificial intelligence comes into the picture here in this particular section. So I think, yeah, it's 3:30 there. So these are the abilities which are there in the BCI, and I will try to bring at least a case study where these things are there, so that you will have more excitement for these areas. Those who are working actually very somehow close to these areas, like signal processing and doing some programming. I hope all of you will be definitely doing some programming, either on C, Python, whatever language. With that, you can easily implement all these things, especially in the analysis part. So CNS comprises of brain and the spinal cord, you have seen in the diagram, and the PNS, which is comprising of peripheral nerves and ganglia and the sensory receptors. Your sensory receptors are outside, like eyes, ears, they all cover your PNS. So PNS and CNS are the parts of body. Outside world doesn't mean that they are separated from the body. So structures of CNS are differentiated by their location within the, let's not explain about because we have seen in the diagram. PNS serves mainly to convey sensory input to the CNS and to convey motor outputs from it. So you can see PNS is an interface between CNS and outside world. PNS sends sensory data to CNS, and PNS also sends output commands to outside world. CNS activity consists of the activities which are happening inside the brain. CNS activities consist of electrophysiological. If you can recall what I was talking about, some laboratories where we are working with, in those laboratories, if you can reconnect that there was some biological, neurological, physiological, neurophysiological. These parameters are very important in order to study the brain and the CNS activities. So electrophysiological, neurochemical, some chemical related signals are also used. I will describe not probably today, but in next lectures. And metabolic phenomena, for example, neuronal axon potentials, synaptic potentials, neurotransmitter releases, oxygen consumption, even oxygen level is also the part of study in the study of brain that occur continuously in the CNS. These phenomena can be quantified by monitoring electrical or magnetic fields, hemoglobin oxygenation, and other parameters with the help of sensors on the scalp, on the surface of the brain, or within the brain. On the scalp, on the surface of brain, this is the first one is actually completely non-invasive. Second is semi-invasive, and the last one is completely invasive. So BCI records the brain signals, then we extract the features we have already discussed, then we convert those features and we translate rather in terms of artificial output. The output may be either command or some feedback signal. BCI output might replace the natural output. Now I'm trying to explain the term replace, which was used there, if you remember. So BCI output might replace natural output that has been lost as a result of injury or disease. So this is important thing. What is the meaning of replace? That has been lost as a result of injury or disease. For example, a person who can no longer speak might use a BCI to type words that are then spoken by the speech synthesizer. These days, from text to speech converter, text to voice converter. So what BCI or how BCI can help? Say the person has lost the speaking capability. The person can understand the thing, person can just type it, what is being conveyed to him, he is not able to express, he can type it and then it can come as a speech. So this is one area where you are replacing, you are giving some replacement solution. The person who is not able to speak is actually, speaking with the help of a machine. And all your speech synthesizers, I understand you all know that there are a number of online, translators are there, converters are there. If you just give your voice as an input, you will get text or vice versa. Or a person who has lost limb control, that was related to speaking loss. And this the next one is the person who has lost limb control might use BCI to operate a motorized wheelchair. He can be guided to use certain commands, and there will be some buttons in the wheelchair, and the person can be guided and how to move forward and how to do this. A BCI output might also restore lost natural output. For example, person with a spinal cord injury. If you remember, I was telling you spinal cord injury or difficulty in spinal cord is also, treated with the help of BCI. So there is a spinal cord injury whose arms and hands are paralyzed. You can understand how badly, the spinal cord injury is. So that has affected arms and hands movement that have become paralyzed. Might also use BCI to stimulate. Remember, if you look at the previous diagram, in one diagram, stimulation was there. So a stimulated signal can be generated, and that stimulation, the paralyzed muscles can be stimulated via implanted electrodes so that the muscles move the limbs. There can be implantation of electrodes through which the stimulation will happen and the paralyzed muscles can start functioning. So I'm trying to explain the restore, replacement, the terms which were present in the previous diagram. This diagram. I'm just trying to explain. And then where were we here? A person who has lost blood, there are different types of losses and replacement we are talking about. where the BCI is playing a role. A person who has lost bladder function control due to multiple sclerosis might use BCI again to generate a stimulated signal to the peripheral nerves to control the bladder and thus enabling the urination. There is some difficulty and even bladders are not functioning. So that kind of stimulation is still, possible. But all these research are, what I can say, not in the tangible output form in the large or wider scale, still in the, research level stage. A BCI output might enhance natural CNS output. Example, person performing a task that requires continuous attention over a prolonged period might use BCI that detects the brain activity preceding lapses in attention, then providing a output. If you remember, I was giving you an example of person who is doing a long, who is driving a truck for a long time. So if you remember, requires continuous attention over a prolonged time. So based on the activity, brain activity, so what will happen when you are concentrating to a activity for a long time, it will have a similar kind of activity, he will be very focused to the road, traffic, and all that. I'm just taking the example of a driver. So there will be definitely lapses, preceding lapses in the natural brain activities. Natural brain activities means the current brain activities of a person where he is engaged in some activity. So then it provides an output, maybe some in the form of some sound, some alert will be generated. And then you can fix the volume of that alert. So if there is, a long beep or long alert which is generated, so that will help the person to resume and regain the work so that there is no loss. So it alerts the person and restores the attention. So what is important here is the term attention. The attention can be, when there is a loss, when there is a lapse, the person can be guided and through the alert signal because of detecting the lapses in the brain signal. So there the work is in real time. Remember, you are capturing the brain signal in the real time and then continuously monitoring the brain signal. When you find that in the brain activity there is a lapse, then you can come into picture. The system will come into the picture and will generate the lapse. So the BCI output might also supplement natural CNS output. For example, person who is controlling the position of computer cursor with a hand operated joystick might use a BCI to select the terms for cursor. Same operation, no need to explain. Or a person might use BCI control to a third robotic arm in hand. In these cases, BCI is supplementing the natural neuromuscular output with the additional artificial output. Remember, so in one of the previous diagram, it was also written either the CNS generate neuromuscular output or the output which is not neuromuscular. And what is that output? Some additional output, like here some robots and other arms are, given the command and they are controlled to operate according to the brain signal. So this is how the BCI works. So I'm just trying to give you enough, fundamentals or theoretical background that what is the potential of BCI in these areas. So it's not only healthcare, but there are many areas where robotics and those supplements and other things can actually help the society. BCI output might improve natural CNS output also. For example, a person whose arm movements have been, this is another example, whose arm movements have been impaired by stroke involving in sensory motor cortex. Sensory motor cortex, the person undergoes a stroke, so he probably might have lost the sensory, ability as well as some movement. Motory cortex means there is an area in the brain that is responsible for movement of your different organs. So there is a stroke and that has affected sensory motor cortex that uses BCI measure signals and from the damaged cortical areas, and it tries to measure the damaged signal from the damaged area due to why the area is damaged because of stroke. Then it stimulates the muscles or controls an orthotic device so to improve the arm movement. So this is how it tries to recover. So you can understand how interesting, the BCI is. Not only we hear the term brain computer interface, it's practically, is a kind of blessing to the society. And if you are really excited about doing some research, you can definitely start with, because I believe that some of you, I was trying to, because I'm not aware about all your background very clearly, but some of you are from some hardware side also. So those who are on both side, working on some hardware and can have understanding of interface, protocols, implementation of software protocols and programming, then definitely they can try working on these, areas. So BCI application enables more normal movements and may induce activity dependent and improves the natural output and helps the person to regain more normal control. I'm sorry. The problem is there is afternoon. Here is a, you know, what time in India now is, 2025 is 8:25 p.m. So I'm in my office area where it has become little cold. So, and I'm only one person who is sitting in the entire office area. Yeah. So the CNS interacts continuously with the outside world and with the body. These interactions consist of the motor outputs to the environment together and sensory inputs from the environment. Before understanding all this, you can, one question can come in your mind. What is this CNS? Why we are talking about CNS? Now you must have understood that CNS is very well interfaced with the even spinal cord, PNS, and how the CNS is responsible in order to address the different stroke and other related things. So I think you'll be able to do this. By measuring CNS activity and converting into artificial output, affect the environment. BCIs change not only through the CNS output, but also the sensory inputs coming from the environment. Means bidirectional BCI. If you remember in the previous slide, there was a bidirectional BCI. So you have seen in the previous slides, CNS activities, they convert into some artificial outputs, but vice versa is also possible. BCIs change not only the CNS output, but also the sensory inputs coming from the environment. So it can have control over the environmental stimuli as well. How much stimuli is actually needed. So this is how, it is very useful. These changes in sensory input are commonly referred as feedback because you are having control over that. Devices that simply monitor brain activity and do not use it change the ongoing interactions and environments are not BCIs. So there are some terminologies now. I will discuss about BCI so that in next lecture we can directly start with basics of signal processing and what are different signals I want to cover, especially the brain signals which are used in the BCI. That would be the focus of the next lecture. So probably in next lecture, we'll only talk about signals. And then next lecture, we'll talk about processing and understanding the signal. Definitely it will involve the signal, feature extraction. So there are some terminologies related to BCI, like, if you remember, I was using one more term called as event related potential. That was different. This is another one, vital, they used a visual evoked potential. There is a similar term which will come again and again when we talk about BCI in several applications. Visual, and you can clearly understand visual evoked means it's, stimulated because of visual impact. Recorded from the scalp or the visual cortex. You can understand there was a motory cortex. Motor cortex is the area in the brain responsible for motory tasks. Visual cortex probably will be in the occipital area that is responsible for visual abilities and that determine the direction of eye gaze like visual fixation point, and thus to determine the direction in which user wanted to move a cursor. A person is having some difficulty. So with the help of visual evoked potential kind of thing, the cursor even can be controlled. The term, there are two more terms which are coming, like dependent BCI and independent BCI. I told you that we are going to talk about, first I have tried to cover types of BCI, invasive, non-invasive, semi-invasive. There are two more terms coming like dependent BCI and independent BCI. Were introduced in 2002. In accord with BCI definition, both use brain signals. In both of them, brain signals are used to control the applications, but they differ in their dependence on natural CNS output. In BCI dependent, it will depend on natural CNS output, whereas in independent BCI, the functionalities will not depend on natural CNS output. Now you can definitely understand, I hope by this time, what is natural CNS output, what is artificial CNS output. In our previous slides, we were trying to understand. And remember, these things, these terminologies, these discussions are very important when you really want to know about BCI and the capabilities of BCI. So dependent BCI uses brain signal depend on muscle activity because the muscle activity is controlled by CNS. For example, BCI described by Vidal, which is at the top. Use the amplitude of VP. What is VP? Is visual yoke potential depends on gaze direction, that is eye gaze direction, and thus the muscles that control the gaze. Muscles means your arm muscles, which is moving the cursor. That's what I'm trying to say. A dependent BCI is essentially an alternative method for detecting messages carried in natural CNS outputs. So natural CNS output has given some command and you are able to do with the help of your muscle. Although it does not give the brain a new output that is independent of natural output, but is still useful. An independent BCI, as I mentioned in previous slide, does not depend on natural. In independent BSI, muscle activity is not essential for generating the brain signals that BCI uses. So, for example, in BCI based on EEG sensorometer rhythm, there is an example called as SMR, EEG sensory motor rhythms. This is example of independent. The user may employ mental imagery to modify SMRs. What is SMR? The sensory motor rhythms so as to control the BCI output. So, the user may use some mental imagery, some imaging, mental imaging can be employed by the user and means first some mental map or imaging map can be created and that map can actually control the BCI output. I hope we will have some more discussion on sensory motor rhythm if time permits in the coming lectures. For people with severe neuromuscular disabilities, this is one example. For people with severe neuromuscular disabilities, independent BCIs are likely to be more useful. At the same time, it is important to recognize that most actual BCIs are neither purely dependent nor purely independent. The output of steady state VP based BCI may reflect user's degree of attention because it depends on gaze, eye gaze. BCIs rely on user sufficient visual information. Why I'm reading all these statements? Because all these statements are, carrying some meaning, they're all important. So I just don't want to, write the bullet points and explain. And I don't want to, lose some important, statement related to BCI. Therefore, I have copied all these lines. BCIs relies on the user having sufficient visual function. The term hybrid BCI, you have seen there is a dependent, there is independent, there is a term called as hybrid BCI. What we are currently doing, you are already knowing, we are talking about terminologies. So there is one terminology called as hybrid BCI is applied in two different ways. It can describe a BCI that uses two different kinds of brain signals, either VP or SMRs to produce the outputs. Because VP is an example of direct, that is dependent, and SMR is the example of independent. So it can use both kinds of brain signals and brain rhythms. And alternatively, it can also describe a system that can combine BCI output with natural muscle based output as well. So it can have all those, natural output and then artificial, which is of two types like that. There is one more term which you can see now is not active but passive BCI, which is applied to BCI applications that utilize brain signals and correlated with the aspect of user's current state. Like example is there where you can understand that what is passive BCI. BCI might detect EEG features preceding lapses. I think I've already talked about this one. There is a lapse in the attention. I have given one example of driving also, or prolonged activity. There the attention loss may be there, so that lapse can be recorded. So there actually the active BCI is not there. You are using the passive BCI and producing an output and that output is not directly coming from CNS, and that output is helping you to alert the user and restore the attention. So whenever there is a poor attention, that can be improved by this one. Why it is passive is mean to differentiate the BCI applications from those that provide communication and control directly. They are under active BCIs where you directly get communication and control directly from BCI output. You don't need to generate other alert and other kind of signal. It directly interprets either commands or some communication feedback signal, for example. So active and passive both are subjective terms and lack clear neuroscientific definition. So sometimes it's very difficult to differentiate both of them. What I can say is there is a thin line difference, in fact, between the both of them. Yeah. So the
Excuse me.
structural and functional imaging methods of high resolution and specificity, chronically implanted devices for stimulating specific structures, molecules, particles can encourage and guide neuronal generation and reconnection, and we can replace lost tissues and rehabilitation regimens that can restore useful function with the help of BCI. A number of new methods which operate directly on brain, unlike BCI, are defined also, and we'll, I think, probably discuss in the next lecture.
Excuse me, I didn't
Yeah,
quite understand the difference between independent and independent BCI. Could you tell some examples, other
very
examples?
Yeah, very good, very good, very good. Actually, we are going to include few examples at later stage. I'm very happy that you interrupted. I was telling you that that is always needed. See what happens that in like if you see there was the discussion on dependent BCI where I was trying to explain the natural CNS output where the CNS output is coming in the form of brain signal and see, although it does not give the brain new output, but there is some output which is generated by the CNS is the example of direct BCI. Whereas see here in the independent, like there was, I think this is a very good slide where you can understand like visual evoked potential. So what happens that visual evoked potential is a signal which is recorded from the scalp and then it affects the visual cortex. So what happens that it creates impression in the visual cortex, and that visual cortex impression, again responds, and based on that response, it determines the direction of eye gaze. So your ability to, your visual ability is changing and affected by this potential. So to determine the direction in which user wants to move the cursor. So this is one example of dependent where you are directly depending on CNS, because if you are going to visual cortex, that's an example of that's integral part of your CNS. Whereas in independent, you are not directly depending on what is called as CNS. Like you see here, it does not depend on natural CNS. Some muscle activity is not essential for generating the brain signal that BCI uses. Like there was one example where you create, actually I have not yet explained the brain imaging, brain maps also. There are some maps which are created. So probably it might, have not helped you to understand very well. So it may imply some mental imagery to modify SMRs. So this is outside. What I'm trying to say is this mental imagery is created outside CNS and the SMRs are created outside CMS based on EEG signal. And this mental imagery is actually controlling the BCI output rather than in the previous case, the CNS output was controlling and you were able to change your eye glaze and eye positions. So I think this is a difference between that is independent and dependent. So VP is coming under dependent, whereas this what is called as SMR is coming under independent BCI. All right, hope I could answer your query.
Yes, thank you.
Thank you so much. But yeah, in the coming slots, coming lectures, many more things, many more applications on these to come, and there you can clearly articulate that which will fall under which category. So see, The natural function of CNS is to produce muscular and hormonal output. So we need to understand it gives two outputs, muscular. So you can understand what I was talking about VEP, right? That visual evoked potential. There is an event related potential will come later. So CNS is to produce muscular as well as hormonal. So if you talk about muscular means the CNS output is prompting some muscles to move, like you are changing your some, you are changing your eye positions. It's because of that visual cortex is prompting you to do, and you will be forced to do, because you have been directed by your visual cortex. So that's the kind of muscular output which is produced by CNS. But this is direct output by the CNS. Second is hormonal output is a kind of signal, the frequency which we actually get, and then further use this frequency in the BCI system that serve the needs of organism by acting on outside world or on the body. So either it is a muscular or muscular will definitely, directly impact the body parts, but particularly the hormonal parts that will serve the purpose of outside world or even on the body as well. A body, how it will help on the body, as I mentioned that there may be feedback signal, there may be rehabilitation scheme. By that, the BCI, is interpreting the hormonal output, and then BCI is generating the feedback signal. So it can, again affect the body, or BCI is otherwise BCI is always, made for the outside world only. So BCIs provide CNS with additional artificial outputs. This is very good, benefit of BCI. Otherwise, CNS outputs alone cannot serve any purpose. CNS output cannot be utilized in the application. CNS output can have the limited capability in the body parts because you are not trying to augment the performance, augment the abilities of human body, and that is also possible, or controlling outside world kind like robotics, something that is also possible by the external output. So the BCI is something that provides CNS with additional benefit of artificial output derived, as I was explaining, the additional artificial outputs have been derived from the brain signals. So brain signals you are acquiring for certain purpose, so that you want some output. This output may be again, some classifier output, or maybe commands or some signals, anything which is being derived from the brain signals using some artificial intelligence model, some feature extraction, training the model, something like that. So that will provide actually the additional output. So therefore, that they require CNS, which has evolved to produce muscular and hormonal outputs to now produce entirely new kinds of the output. For example, there is an example like semi-motor, sensory motor cortical areas. I was trying to explain you what is sensory motor cortical areas, where the area, the person will be responsible for sensory as well as especially those motory tasks where you have some, sensor based thing. Your eye blinks are affected, some sensor input, stimuli input. So that will definitely be controlled by this. So which normally interact with subcortical and spinal areas to control muscles, and us instead to control certain brain signals. I believe that, I can accept that there are a lot of things about CNS we are talking for a long time. Some of the statements might create some confusion. I understand definitely. But once we go to some application level where we'll have some flow diagram, we'll have some algorithm, we'll have some block diagrams, we'll get more clarity. I wanted to include some more pictures on CNS, but I avoided. So let's talk about brain activities. We are talking about the terminologies. So let's talk about brain activities. We are saying that brain activities are something which is common either in CNS output, or the brain activities are interpreted by the BCI, and artificial outputs are generated. So what are brain activities? And the brain activities are of three types major. One is electrical, and you can clearly recall and reconnect that electrical activities are recorded in the form of EEG. So electrical activities are, and remember, these are actually the activities which are, present inside the brain. So electrical activities are there. chemical activities are there and metabolic activities are there. And the signals related to all these activities are used in the BCI and in the study of brain for different purposes. So also known these is the known of this is electromagnetic activity that results in neuronals or neurons action potential. What is called as probably EEG is missing here from here, which is itself the result of chemical events occurring in around the neuron. So the meaning is sometime when we say electromagnetic activity, that is also controlled by some chemical events which are occurring in and around the neuron, because there is a bundle of neuron and that actually is responsible to generate certain amount of potential. So there is some electromagnet. Even remember something which is not coming here is magnetic. Like I hope I have told you about the modalities, just introduction to the modalities in the last lecture. Like EEG, there is another modality called as magnetoencephalography. So when we're saying magnetoencephalography, so electromagnetic activities are there inside the neurons. So action potentials and other neuronal electrical phenomena allow for electrical measurement of brain activity with EEG. Then something which is related with magnetic field, magnetoencephalography, electrocardiography. You have seen this comes under what is called a semi-invasive BCI, or with microelectrodes implanted in the brain tissue. So the first actually two things are actually under your non-invasive. Next one is under your semi-invasive. And if you're inserting microelectrodes and you are implanting inside the brain tissue, that comes under the invasive technique. But we are actually interested to understand all these activities and what are the signals responsible to all these activities. That's the idea. We are moving to that side. So EEG and MEG are located far from the neurons. Therefore, I mentioned they are non-invasive. And the signals acquired do not allow precise identification of active brain. And this is why the signal strength is weak. Despite the fact EEG is most popular, is because of, I have already given you the reasons. The orientation of neurons to the sensors strongly affects the measurements. How neurons are oriented, that affect the measurements, and particularly neurons relative to the sensor. For example, I'm hearing. So those neurons, how those neurons align to hearing capability means the area you have seen in the structure of the brain. Some area is responsible for hearing capability. So all the neurons of your brain, how do they align? How do they orient towards that particular area? That also affects the measurement. Some brain regions are less visible to these sensors because the neurons will be more aligned to particular regions, and that will be more visible when you record the pattern. So you have seen in a diagram that you are capturing some brain signal from particular part of the body. It's not necessary to entirely cover the whole skull. It is depending on what kind of study you want. So neurons will be attempting to align or attempting to orient towards that part of the brain. Electrodes placed directly or within the cortex measures electrical activity. We are talking about electrical activity and the immediate vicinity, but they can cover only a very limited part of the brain because it is there, the outside of the brain. The brain activity can also be detected. Now coming to the next activity. In the previous slide, the activity was, mostly electrical. Now coming to chemical processes, let's talk about one example. And remember, today I have not told you the details about EEG. Of course, when we are talking about BCI, I must tell you some description about EEG and other signals, especially covering all these three activities. So the next you can see, and many of you might have heard, those who are aware of image processing, there is another kind of image modality called as PET, position emission tomography. So this is something which is related to chemical process. Really, brain activity can also be detected by chemical process detection, but the methods for doing so in humans, mainly by PET, are still rather crude, involve injection of, especially look at here, it's also very painful. It involves injecting the specially manufactured markers and have poor temporal resolution. Even taking a lot of risk, the resolution is not very good. And But what I want to tell you, PET is also a technology, what is called as modality that is also used to capture the brain signal, but that does not record electrical activity. What I'm trying to say, that records chemical activity. You know, due to limitations of electrical and chemical methods, much effort has been invested in measuring metabolic process. So metabolic process, it involves utilization of energy, like I was talking about some time ago. I hope you all understand, whenever we talk about energy in the brain, oxygen level comes into the picture. So after some time you will see the oxygen level. So oxygen level is also the important parameter in the study of brain. When neurons increase their firing rate, they use more energy. Obviously, I can tell you one thing. When you are in critical thinking, you have seen in the last lecture, you have seen that there were EEG waves which were given. And in the critical thinking, why the frequency was higher, you can definitely understand. Because in the thinking, you apply a lot of energy. And you know that whenever, you all know, if you are having signal processing and communication background, right? More is the energy, more is the frequency, right? So therefore, energy was high. So you see here, when neurons increase their firing rate, they use more energy. This energy is supplied by chemical reactions in and around the neurons. The increased metabolic activity increases the demand. Whenever there is an increased activity, that is metabolic activity related to energy, there is a demand for basic fuels like metabolism, glucose, sugar. I was telling you about the oxygen. So it will demand for more glucose and more oxygen. So if it is, there is a term coming as a glucose, you can find a lot of research on diabetes also. Those who are affected, those who are diabetes patients, there are some work which are going on by using these brain signal. So these changes in demand can be detected because it is accompanied by increased blood flow to the region. So the level of oxygen, the blood flow in the brain is highly controlled and locally regulated. It acts as a marker for neural activity. So therefore, a lot of markers are inserted and we try to capture. Like this is first picture is about your electrical and magnetic field. The is intracellular current dendrites. These dendrites are the parts of neurons from where you are getting it. And this picture has already appeared before. It is actually measuring your electrocortical cartography, which is actually uh, what is called is semi-invasive technique where you can still get more amount of data. This is definitely PET, that is position emission tomography, where as you have seen that blood flow can be, observed. How is the blood flow? Which area is having more blood flow? Whether the blood flow is normal or not. Like this particular diagram at the top, is generally, because how do you get generally that based on a lot of experimentations on the normal persons, based on a lot of surveys and a lot of experimentations and the data analysis, it was found that these maps are for normal person. These maps are for normal person. So, and if you, I have already talked about the Parkinson's disease, that's a mental disease. So if it is in the, what I can say, early stage, pre-Parkinson's, that will look like this. But you see here, the post-Parkinson's, the blood flow, is very abnormal. So the blood flow will be towards certain areas very abnormally, and that will even cause, even fatal problem in the brain. And this is why I was telling you that time, even the brain tumor, the Parkinson's disease, the blood flow, all these are the important parameters to be taken care of while studying BCI and doing the research. Another term, I think we are coming to the end and we have another 4 or 5 minutes. So another term, because we are talking about resolution, resolution is an important factor. As I have mentioned that in EEG, the resolution is poor. Obviously, when you go for inserting the marker, resolution will be better. So spatial and temporal, both are measured in terms of resolution. Distance between two adjacent points in space or time can be distinguished from each other. So I'll explain the spatial resolution and temporal resolution again, coming to, getting in the form of images or videos. For example, it has given one example, digital photography, a photo taken with 1 megapixel camera produces image consisting of squares and does not show much detail. In contrast with 10, I mean, it will definitely give the detail, but when you say 10 megapixel image, it will give more details. Those who know about image processing, they know it very well. You just can compare, color pixel with a gray pixel, gray scale image, that is white pixel. So in color pixel, what happens that one pixel can be represented by 24 bits, whereas in black and white picture, one pixel can be represented by 8 pixels. So the more number of pixels are involved in the, I'm sorry, more number of bits, rather more number of bits, because we are talking about megabits pixel. So more number of bits are involved to represent one pixel, like 24 bits in color pixel and the black and white pixel, 8 bit generally. So there you'll get better resolution. And size of squares, much smaller, higher resolution image called the resolution. The term resolution is used in brain imaging, much smaller for higher resolution. So if you're obviously, if you are putting, less area for each square where you are concentrating, again, the number of pixels which will be required in order to represent the image will be more. So that is used, but I think we are again going to use all these terms in the numerically and implemented in the results, which I will be including in probably after 4 or 5 lectures only. Since the measurements in brain imaging are in 3 dimensions, this is what I was trying to tell you. Voxel, because you in particularly in metabolism, metabolic observation, you also record video. So we don't call that time pixel, we rather call it as voxel. Volume element is used instead of picture element, and there both resolution matters. So spatial resolution of 1 mm means each voxel. Now coming to spatial resolution. 1 mm means each voxel has a size of 1 mm along each side, because it's a volume kind of thing. Video is there, so it's a 3D kind of thing. So you have a spatial resolution. But I think this is the time to, I mean, we can stop here only, and then we can continue, because I think how many? Yeah, we still have 3 minutes today.